In this video, you will learn about the slope of a line. Now, as we begin, we need to define our terms. What does slope mean? Now, slope is how quickly something goes up. So, a way of thinking of this could be maybe the steepness of a line. So if it goes up more quickly, if it's more steep, it has more slope. If it is less steep, it has less slope. Now it's important to know how to quantify slope. It's not enough just to say that the slope is large or it's greater than this other slope. We want a way to put a number to the slope. So we can do this in different ways. One way is by looking at the graph. So slope is how quickly something goes up within a given amount of distance across. Or maybe a more clear way of saying this is it is the rise over the run. So rise is how far the line is going up, and the run is how far the line is going across. Okay, just like in English, rise means to go up, run, you run across the ground, not up into the sky. So rise is up, run is across. So looking here at this line segment, we're going from this point up to this point. So notice that the rise is going to be up 3. So it goes up 3, and then it's going to go over 8. So the run is 8. So the slope is the rise over the run, or 3 over 8. Here's another example. So again, slope is rise over run. So notice that it's going up 6 and then over 2. So over 2 and up 6. So the rise is 6, the run is 2. So my slope is going to be 6 over 2, which can reduce to give me 3. Okay, here is another example. Now in this case, the line segment is going down this direction. Again, the slope is rise over run. So if we're looking from left to right, we're starting at this point right here. To get to this point down here, we have to go down 5. So the rise is a negative 5. Okay, down is the negative direction. And then the run is a positive 9. Okay, so it's going over to the right 9. Right is the positive direction for the run. So I have negative 5 over a positive 9. So my slope is negative 5 over 9. Here's another example. To find the slope by looking at the graph, we take the rise over the run. So looking at this graph from left to right, rise from this point, we have to go down 2. And then we go to the right 4. So the rise is a negative 2. The run is a positive 4. So negative 2 over positive 4 can reduce, and that gives me negative 1 over 2. So the slope in this case is negative 1/2. Now we can just look at the graph and determine the slope. However, we want to quantify the slope by calculating and not have to look at the graph every time. We want a method that is quicker and simpler instead of having to count every time, because counting is not the most accurate, especially if the point is not exactly on a number. Maybe it's a fraction. Maybe it's 3.5 for the rise and 4 3/4 for the run. Okay, we need to know how to determine the slope without having to guess with those points. So here is a process for quantifying the slope by calculating. So we see here our 2 points. We have negative 7, negative 2, and 1, 1. So yes, we could count and quantify the slope, but the objective is to calculate. So again, slope is rise over run. And we can count, and we see that it goes up 3 and it goes to the right 8. Okay, but how do we find those numbers, 3 and 8, without counting? So to do that, the rise, notice the yellow or the y values. We have -2 and +1 for the y values. Y is the up and down direction. The y-axis is this vertical line. So if I look at those y values, -2 and 1, notice if I subtract the two values. If I take 1 minus a -2, that gives me a +3, right? 1 minus -2 equals the 3 for that numerator. So that gives me the rise. The run, look at the 1 and the -7. If I do 1 minus -7, that's going to give me 8. So that's going to be the numbers for the rise and for the run. The rise, we subtracted the y values, and for the run, we subtracted the x values. And that's my formula. My formula is I subtract the y values and then divide that by the subtraction of the x values. So this notation, we see y2 minus y1, x2 minus x1. This just means the two different y values. So for example, with the 1, 1, and -7, -2, so 1, 1, we can let this first number right here, this red 1, be our x2. All right, this is our second x value, x2, and then 1 would be y2. -7 can be our x1, and -2 is y1. Okay, we do that because this whole ordered pair, we can call that point 1. Then over here, this could be called point 2. So our point 1 has the 1's with them, with the x and the y. Point 2 has the 2's with them. Okay? So from here, we can subtract, like we just did. So we do the 1 minus -2 over 1 minus -7. That gives me 3 over 8. Okay, now take note that when we're doing this, it also does not matter which one is point 1 or which one is point 2. If I wanted to, this could be my point 2. So then this would be x2 and y2. Then over here, this could be point 1. And then this would be x1 and y1. All right, if I do it that way, we do x2 minus x1. So we do, y2 minus y1. We do -2 minus the 1. So switch the order of subtraction. -2 minus 1 over then x2 minus x1. We have -7 minus 1. If we do it this way, we get -3 over -8, which the two negatives divide out to give me a +3 over 8. So it doesn't matter which one is point 1 or point 2 as long as we are consistent, and point 2 has the x2, y2. Point 1 would have the x1 and y1. And as long as we're consistent with the formula as well. Okay, here's another example. So we have a line that goes through points 3, 2 and 4, 6. And we are to determine the slope just given the points. So remember, slope is rise over run, or y2 minus y1 over x2 minus x1. So if we let this be our point 1, this is our first point, and then this is our second point. If we do it this way, then this would be x1 and y1, our first x value and our first y value. This would be x2, and this would be y2, our second x value and our second y value. So from here, I just plug in numbers into the formula. 6 minus 2, that's the y2 minus y1, over 4 minus 3, which is our x2 minus x1. So then I subtract, I get 4 over 1, which would equal 4. So the slope of the line that goes through these 2 points is 4. Okay, here's another example. Find the slope of the line that goes through these 2 points. So again, we have slope equals rise over run, which is y2 minus y1 over x2 minus x1. So if we let this be point 1 and then point 2, this would be x1 and y1 and x2 and y2. And then we just plug into the formula. Negative 2 minus 4 over 5 minus negative 3. So that gives me negative 6 over positive 8, which can reduce to get negative 3 over 4. Okay, now what if you are not given 2 points? Let's say instead we are given the equation and we are to find the slope. Now, to find the slope, we need 2 points, right? So we can find any 2 points on the line. So what I can do is the same way that we graph this equation, we can plug in something for x or for y, and then try to determine the other value. And we can get 2 points that way. So for example, if we plug a 0 in for x, we would get 3 times 0 minus 4y equals 12. So 3 times 0 is 0. So we have negative 4y equals 12. And then divide both sides by negative 4, y would equal negative 3. So my point would be 0, comma, negative 3. And then now that we have 1 point, we can do that again. And let's plug a 0 in for y this time. So if y is 0, then we have 3x minus 4 times 0 equals 12. So 3x, and this is 0, so 3x would equal 12. Divide both sides by 3, x equals 4. So my point is going to be 4, comma, 0. So I have 2 points. And from here, to find the slope, I use my slope formula, y2 minus y1 over x2 minus x1. So this would be x1, y1, x2, y2, and I subtract. So 0 minus the negative 3, so y2 minus y1, over 4 minus 0, the x2 minus x1. So for the top, I get positive 3. For the bottom, I get a positive 4. So the slope is going to be 3 over 4. And I will say that this process of finding the slope by finding 2 points, if you have the equation, this is actually the long way of doing this. There's a shortcut method we will explain in a later lesson. But until then, this is one way that you can find the slope of a given equation. Now let's look at 2 more examples like this, where you are given the equation and you are told to find the slope. So here we have the equation x equals 6, and you are to find the slope of this line. So graphically speaking, we know that it's going to be over here at 6 on the x-axis, and it's going to be a vertical line at 6. So the question is, though, what is the slope? So what I can do is pick any 2 points on this line. So, for example, if we go over 6 and up 4, 1, 2, 3, 4 right here, that is 1 point on this line. So we could do 6, 4 if we wanted to. We could do 6, negative 1 if we wanted to. We can pick any 2 points, it doesn't matter. And we're going to use these to find the slope. So if we have 6, 4 and 6, negative 1, find the slope. So to do that, we're going to use our slope formula, y2 minus y1 over x2 minus x1. So this would be x1, this is y1, x2, and y2. So I plug in the numbers, negative 1 minus 4, that is y2 minus y1, over 6 minus 6, which is x2 minus x1. So I'm going to get a negative 5 over 0. So negative 5 over 0, which anything with the 0 underneath is undefined. So underneath, undefined. So the slope in this case is undefined. So this vertical line will have an undefined slope. Okay, now what if we had y equals negative 2, and we were to find the slope of this line? Well, to do that, if we can picture the graph, y equals negative 2, that's going to be a horizontal line here at negative 2, because we go down 2, and y will be negative 2 no matter what. So what I can do is I can pick any 2 points to determine the slope. So we can pick maybe 0, negative 2, and 4, negative 4, negative 2. So if I pick those 2 points, I can then calculate the slope by using my slope formula. So we have m equals y2 minus y1 over x2 minus x1. All right, so if we let this be x1 and y1 and x2 and y2, we just plug numbers into the formula. So we have y2 minus y1, so negative 2 minus negative 2, over x2 minus x1, negative 4 minus 0. So negative 2 minus negative 2, that becomes a plus 2, which would be 0 for the top. Then negative 4 minus 0 is negative 4 on the bottom. So 0 divided by anything will equal 0. So the slope of this horizontal line is going to be 0. All right, so horizontal line has 0 slope, a vertical line has undefined slope. So to finish off, we have different types of slope. Okay, we have positive slope, which is going to be a line going like this. All right, so going from left to right is increasing, getting bigger. So that's positive slope. We have negative slope, which is going to be going down this way. So from left to right, this line is going down. That's negative slope. And then we said a vertical line has undefined slope because we have something divided by 0. And then we also have 0 slope, which is a horizontal line. This horizontal line has 0 slope. And so what we have here is a little way to remember the different types of slope. We have positive, negative, undefined, and 0 slope. And we give this guy a little name, and his name is Mr. Slope Guy. So he can help you as you try to remember which types of slope we have given a particular line. And that concludes our lesson for today. We will see you next time.